I'll start the lecture on the problems for levels 3 and 4. So level 3, find the total number of sets of non-negative integers w, x, y, z such that w is less than or equal to x, is less than or equal to y, which is less than or equal to z, such that this statement is true, which is 5w plus 3x plus y plus z is equal to 100. So the first thing we can do is make a substitution. And the point of the substitution is so that we can satisfy this condition without having to use these lesser than equal to signs. And so let a equal w and b equal x minus w, and then c is equal to y minus x, and finally d is equal to z minus y. And so because of these inequality signs, we know that A, B, C, and D are all at least 0. And that just means that they're all non-negative. And next, we can substitute these values into here because W is equal to A, X is equal to A plus B, because we can reverse these. And so what we find is that W is equal to A, X is equal to A plus B, Y, that's a bad Y. Y is equal to A plus B plus C, and Z is equal to A plus B plus C plus D. And so when we substitute this into here, what we find is that this is equal to 5A plus 3 times A plus B plus A plus B plus C plus A plus B plus C plus D. And if we combine like terms and simplify it, then what we get is that this is equal to 10a plus 5b plus 2c plus d. And this equals 100. And so from here on out, we can consider these in blocks of, okay, consider this in blocks of 10. So what we mean here is that we're basically just splitting this into 10 groups of blocks of 10. And so there are a total of 3 kinds of blocks of 10. And so the first case 1, is literally just has 4 different kinds of blocks. The first block is literally just 10 ones. The second kind of block is 5 twos. And the third kind of block is 2 5s, and the final kind of block is 10. And the reason 10 is important here is because 10, 5, 2, and 1, D, because the coefficient of D is 1. And so what that means is that all the coefficients of these terms are all divisors of 10. So these 4 blocks are the 4 different kinds of blocks that will appear in the first case. And if we do these 10 blocks using only these kinds of blocks, then this is equivalent to having 2 stars and bars, where there are 10 stars or blocks as written here, and 3 bars, because there are a total of 4 different kinds. And so the number that ends up getting counted here is just 13, choose 3, which is 286. So for each case that we count, I'll end up including the final count in a different color. Now for case 2. And in this case, there is at most one block of this specific kind. And it's using 5s, 2s, and 1s. And so the reason why there's at most one block is because if there are 2 blocks of this kind, then some kind of block 1 block will appear, and that just defeats the whole purpose of this case. And so at most one block can be used. And so the number of ways this is possible is, the first case is 2 plus 1 plus 1, and this is a total of 8 ones. The next case is 2 plus 2 plus 1, and total of 6 ones. And now the third case is 3 2s and 4 1s. And now the next case is 4 2s and 2 1s. And so if we have a total of 5 2s, then this would count as a case in block 1, which is not good. And so now we can go to 5s. And now if there's a 5, and the remaining would be 5 1s. And so 5 1s, and then the next case is a 5, a 2, and 3 1s. And the final case here is a 5, 2 2s, and 1 1. And this is a total of 1, 2, 3, 4, 5, 6, 7. 7 cases. And now up here, if we remember, using stars and bars, but now there are only 9 blocks available. So the number is 12, choose 3, times the number of ways we can choose one block from this case. Since there are a total of 7 kind of blocks here, that means we multiply by 7. And so this number is equal to 220 times 7, or 1,540. And now there's one final case. So case 3. And in this case, there is also at most one kind allowed. Except this time, it's a larger block of 20. And it's really quite similar to this case, except in this case it's a block of 10, and in this case it's a block of 10, and this case is a block of 20. So there's only 2 cases here. So the first case is 5 plus 2 plus 2 plus 2, and so this is 11, and the rest is 9 ones. And the other case is a 5 and then 4 2s and 7 ones. And so that's 2 cases. And so now we can use accounts. However, we can't, if we use a case 3 block, we can't use a case 2 block. And the reason for that is simply because of similar reasons. Because if we do that, then we'll either see 10 ones, 5 2s, or 2 5s. And then that would just not work anymore. So for this case, 12, just like how this had 10, and then this case 2 had 9, case 3 now has 8 blocks and 3 bars. And so that leads to 11, choose 3. And now there are 2 cases here. And so we multiply by 2 for similar logic to this case. And so this is equal to 165 times 2, which is 330. And so now we have our numbers from the 3 cases. And so the total sum is just 286 plus 1,540 plus 330. And this is equal to 2,156. And so that's the answer. So now let's move on to the level 4 question. So let A, B, C be real numbers that are at least 1. And so show that basically the minimal value between 10a squared minus 5a minus 1 over b squared minus 5b plus 10, 10b squared minus 5b plus 1 over c squared minus 5c plus 10, and 10c squared minus 5c plus 1 over a squared minus 5a plus 10 is at most ABC. And so, first of all, we can just completely ignore this condition for now and just focus on finding things in terms of 10a squared minus 5a plus 1 over a squared minus 5a plus 10. And so if we focus on this and find some bounds on it, and we do the same for b and c, and then we multiply them together, then we should be able to prove this. So first of all, these terms are somewhat similar to that of 5 choose 0, 5 choose 1, and 5 choose 2. And so knowing that, we can then look at a minus 1 to the power of 5. And if we expand it out, we can just see that it's equal to a to the 5th minus 5a to the 4th plus 10a cubed minus 10a squared plus 5a minus 1 is at least 0. And the reason for the minus is simply because there's minus signs here. And so what this gives us is 10a squared minus 5a plus 1 is less than or equal to a to the 5th minus 5a to the 4th plus 10a cubed, which if we factor out a cubed is equal to a squared minus 5a plus 10. And so now we have that. And so we now have that a squared minus 5a plus 10 is equal to a minus 5 halves squared plus 10 minus 25 over 4. And this is equal to a minus 5 halves squared plus 15 over 4. And this is clearly greater than 0 by the trivial inequality. And so that means that we can divide both sides by this. And so what we get is that a cubed is at least 10a squared minus 5a plus 1 over a squared minus 5a plus 10. And now we can see that this is quite similar to this. And now we also have that 10a squared minus 5a plus 1 is equal to 10 times a minus 1/4 squared plus 1 minus 10 over 16. And this is just equal to 10 times a minus 1/4 squared plus 3/8. And once again, by the trivial inequality, this is greater than 0. And so this is also at least 0. And so now if we do similar things for b and c, we can find out that b cubed, we can just replace the variable a with the letter b, and it will still hold. So this is true, and this inequality is also true. And so now we can multiply together. Now we multiply all of these together. And so what that tells us is 10a squared minus 5a plus 1 over a squared minus 5a plus 10 times 10b squared minus 5b plus 1 over b squared minus 5b plus 10 times 10c squared minus 5c plus 1 over c squared minus 5c plus 10 is at most a cubed, b cubed, c cubed. And so if we rearrange this so that we can see it more in terms of this, what that gives us is simply 10a squared minus 5a plus 10 over b squared minus 5b plus 10 times 10b squared minus 5b plus 1 over c squared minus 5c plus 10 times 10c squared minus 5c plus 1 over a squared minus 5a plus 10. And this is at most ABC cubed. And now, if the minimal term of these three, is greater than ABC. So assume for the sake of contradiction that this is true. Now, what that tells us is that, what that means is that the product would also be greater than a cubed, b cubed, c cubed. But here we see that this product is actually less than or equal to abc cubed. And so that leads to a contradiction. And so what that means is that this is false. And so the minimal term of the three is actually less than or equal to ABC. And so that was what we wanted to prove. And so we're done.